OK， 我當已經係 break 咗啦。OK， OK， so we have discussed measurements, sort of ad hoc 嘅 measurement。ad hoc 嘅即係話好似好隨意隨機嘅，即係咁 software measurement， 我哋 do we have some measurement specifically for software? Okay, because the measurement that I have been talking about since the beginning of this class is not specific to software. So here are some measurement very specific to software. One very trivial one is line of code as measurement. So what this measurement can be used is, well, it can be used to measure the amount of work done by a programmer. So suppose normally, okay, if everything else being equal, as someone writing 1,000 lines in 1 week is more maybe more productive than someone write 200 lines. In fact, the 1,000 line person is 5 times as productive as the 200 lines, assuming that 1,000 line is really 1,000 line. Okay, of course we know some people would write very clumsy code, and they take 5 lines to do the job of 1 line. That may be exception. Okay, but assuming that the 1,000 lines are the same, all the lines are equal quality, because you can use other measurement to measure the quality of their work. But just based on productivity or size of the software, line of code is one measurement. Okay, and a computer scientist called Halstead, he proposed a term called software science. Okay, many years ago, so exactly 40 years. So he invented terms like vocabulary, length, volume, level of abstraction, and estimated development effort. Okay, so he's thinking that, okay, so let's see what this variable means. Small n1 means number of operators used in a program, distinct one. Okay, what are they? They are maybe arithmetic operators, logical operators, or method calls. Okay, so this is the distinct operators used in a program. Small n2 is the distinct operands. For example, a variable is an operand, a constant is an operand. Okay, and big N1 means number of times operators are used. Big N2, number of times operands are used. Operands 就係 constant and variable啦。Okay, so these numbers, we can use this number to determine small n and big N, and that we can take. He proposed to take this, to calculate this as the volume. Okay, so how do we interpret the volume? So volume means a program that's big volume means it's more work, right? So how does it depend on the big N and small n? Okay, so for the volume, if we increase the number of times operators are used, then double this operator's usage will double the volume, okay, because it is just n. But let's say for the number of distinct operators, the contribution is smaller, okay. Let's say this is log 2. If a program use 4 times as much as get distinct operators in a program， 即係話 如果 base on 呢度咧，我哋其實可以試下計咧，就係 let's say 有兩個 program， 有一個 program 嘅 small n 咧係另外嗰個 program 嘅 small n 4倍。咁我想問你，佢哋個 volume 係差幾多咧 ？OK， 如果 base on 呢度咧 ，log 4 base 2咧就係2啦。OK， 咁即係話咧，如果譬如 program B， 所有呢啲其他嘅 number 都係一樣，但係佢嘅用嘅 distinct 嘅 operators 咧係 program A 嘅4倍嘅時候咧，佢個 volume 咧就係 exactly 係大2倍。OK， 咁然之後又再可以計，即係大約呢個係咁樣嘅計法啦。咁然之後再計埋嗰個abstraction 咧，個 abstraction 係點計咧？就係2 divide by n1。OK， and then n2 small n2 divide by n2， 即係話咧，如果當 n1 係越大嘅時候咧，個 level of abstraction 咧就係越少啦 ，level of abstraction 越少。但係由於個 L 咧喺呢個分母嗰度喎，所以當 L 係越大嘅時候咧，個 effort 就變咗越細，因為呢度當個分數入邊咧個分母越大咧，個 effort 就越細。呢個 E 係嗰個 effort。OK， 咁換句話講咧，即係佢係 base on 呢4樣嘢去計嗰個嘅 total effort。OK， 但係先 let's not talk about whether this is but first 首先我哋話其實佢呢個計法去計個 piece of software 需要嘅 effort 係有幾多嘅時候咧，有冇用咧？你哋覺得呢個方法有冇咩用咧？嗱，有一個好大嘅 limitation 咧，就係佢咪要寫晒個 program 先至可以計到出嚟咯。既然寫咗個 program 嘅時候，如果我計我嘅時間係用咗幾多嘅時候，嗰度咪已經話到俾我聽個 effort 咯。咁嗰個先至係真正嗰個 effort， 而你用呢一啲用個 program 入邊用過幾多個 operator， 即係幾多個 method call 幾多成啊，咁幾多個 operand 啊之類咁樣，或者用咗幾多次 call 咗幾多次，即係呢個可以計出嚟嘅，俾任何一個 program 你。但係嗰陣時我已經有個 program 啦，你再嗰陣時先至計我需要幾多嘅 effort 俾我。其實呢個用途唔算係好大咯。OK， 即係可能第一你要計一大餐啦，咁同埋嗰陣時 suppose 我應該係可以 measure 個 programmer 係用咗幾耐時間去做嘅時候，咁就譬如做唔到其中一個 estimation， 即係 software measurement 嘅個效果就係咧，如果我哋想咧就係想攞個 measurement 咧去 predict 呢個 program 要用幾多時間，但係咁變咗即係喺呢個咧喺個用途上面咧已經係打咗一個相當嘅折扣。咁究竟佢呢個係準唔準咧？我估即係可能都唔係太準啦。如果即係亦都即係未必個效果係特別理想啦。咁所以 end up 唔係好多人用呢個，即係雖然呢個係即係曾經即係好多人知嘅結果。OK， 即係出名嘅，即係 Halstead 嘅 software science 係出名嘅，但係出名is more because this is probably one of the earliest effort to scientifically measure the effort to write a program, but it's not may not be very helpful, may not be very useful. So some people McCabe use a number called cyclomatic number. Okay, cyclomatic number can be calculated by the number of branches plus 1. For example, take this program code as an example. We don't have any branch here, so the branch is 0. So based on this formula, 0 plus 1 is 1. So this code has cyclomatic number of 1. And this code has one branch, okay, a if statement. So the cyclomatic number is 1 plus 1 equals 2. So you can see when the cyclomatic number is larger, it means it's more complex. But is this method good? Well, maybe not, because look at this two programs. These programs have both have two branches. Okay, if. This is the top is program A, the bottom is program B. Both of them has cyclomatic number equals 2 plus 1, which is 3. But we may argue that program A is more complex because the branch nest. This one does not nest. Okay, so if then else, if then else. But this if then else is nested inside that. So we feel probably we would think program A is more complex because it's nested. Okay, and if you don't believe me, try to add this to 2, 3, or 4 level. Then it's way more complex than several if then else more in a straight line way. So this cyclomatic is one way, and also is actually help us for testing. Okay, it helps us to do testing, and okay. And let's look at these other ones. Don't know how to pronounce their names, but in early 90s, they proposed some measurement for OO programs. Okay, so but I won't be going through all of them. Okay, I'll just go through some of them. Lack of cohesion method, okay, LCOM. Okay. It tries to calculate this number by pairing up methods in the same object. Okay, so if two methods inside an object access the same data member, okay, at least some data member is the same, then we say it's similar. Okay, and if two methods do not access the same members, then we say they are dissimilar. Okay， 仲而家嘗試 remind 翻大家咧，嗰個 idea 就係 coupling 同埋 cohesion。OK，coupling 咧就係當兩個 object 或者兩個 subsystem 嘅時候咧，有兩個 subsystem 喺度。OK，we have two subsystems，and if there are lots of dependency between the two subsystems, then we say this is tight coupling. Okay, tight, and tight coupling is bad. Okay, so that means if you have an object in these systems, it calls a lot of objects in this other subsystem, then is tight coupling. We think it's bad. Why is bad? Because if there is some change you want to make to this object, well, maybe it affects the other subsystem a lot because of the call between them. So coupling 嗰個 idea 咧就係話，其實我哋講過 coupling 同埋 cohesion 咧係一個 coin 嘅兩面。OK， 譬如如果我有兩個 subsystem，we have lots of objects in the two subsystem. We want most of the calls happen inside the same subsystem. Okay, we don't want to call very far away. Okay, so if because that's the whole idea is you want to put related stuff together, so they will be calling each other a lot to accomplish whatever they need to do. So if we have lots of calls crossing the boundary, then it's not so good, okay? Or it could increase the maintenance effort. So now back to this cohesion. So cohesion 就係when we say cohesion, it means if we need something, it's likely inside the object, okay, or inside the subsystem. That's cohesion. So that's why we want, in generally, if we say an object is cohesive, that means many of their methods will be sharing data, okay? 如果呢幾個 method 同一個object 入邊，佢嗰幾個 method 咧，從來都冇 data 係 share from 嗰個 object 嘅，就即係話其實你好似係夾硬將佢哋擺埋一齊咯。我哋就係想將啲真正 relate 嘅嘢擺埋一齊。咁既然如果佢哋係 relate 嘅時候咧 ，probably 咧就係需要係 share 一啲嘅 data。所以我哋當 share 啲 access 嘅 data 咧係 inside 一個 unit，let's say different methods inside the same object. So that would be good. Okay, now, and outcome can be calculated by using the number of dissimilar pairs of methods minus the number of similar pairs of methods. So, and also we say lower outcome is better. So that means more pairs similar, the better. More pairs dissimilar is worse. Okay, and if sometimes this is larger than the other one, similar pairs count greater than the dissimilar count. When we give it 0, okay, we assume 0 if the above equation give us negative. So let's look at this example. In this example, we have 4 methods, okay, and 6 variables. And method 1 use variable 1 and variable 3. Method 2 use variable 1 and variable 4. So now, let me ask you, is M1, M2 similar or dissimilar? Okay. Similar, right? Because they share, okay? So M1, M2 is in the similar pair. So if we go, so all these M1 係可以 pair up with 2, 3, 4啦，然之後 M2 又可以 pair up with 3, 4，M3 又可以 pair up with 4。So 我哋係有3加2加1，總共有6個 pair，okay, can be pair up by the methods. And by looking at if they have any variables, we can have something like this. Okay, so dissimilar pair is 2, count is 2. 呢個唔係 next slide 啦，因為我搬咗過嚟。咁呢個咧 similar 嘅咧就係有4喎。Using 個 formula 喺嗰度咧，2減4就係-2啦。咁既然係-2咧，我哋就 assign 0去呢個 outcome。咁0 is the best number we can expect，OK？因為我哋係冇呢個 negative number 嘅，OK？所以如果係，但係如果調翻轉 ，OK？M1 就淨係用 V1。M2 就淨係用 V2，M3 就用 V3 and 4，M4 咧就係用 V5 and 6。咁佢哋咧，如果喺咁嘅 case，我再講一次嚇。嗱 ，M1 就用 V1，M2 就用 V2，M3 咧就用 V3、V4，M4 咧就係用 V5、V6。咁有幾多個 dissimilar pair 咧 ？OK， 我好似有6個喎 ，OK， 因為佢哋係冇嘢 overlap 啊嘛 ，OK， 咁而嗰個 similar pair 咧就係0咯 ，OK， 咁所以喺呢一個 case 咧，如果我正話舉咗嗰個例子咧，就係佢係一個outcome 咧就係好高啦，咁係 undesirable 嘅，因為 lack of cohesion is something bad we want to avoid. Okay, I was